Disco Ladyada.
Hey everybody, and welcome to a Sunday night Ladyada o'clock, as it were. It's me, Ladyada, at my desk. With me, Mr. Ladyada on camera control. I've got some fun Disco Ladyada news, some hardware updates, did a whole bunch of PR testing and a hardware building this weekend. So that's all good, and we'll also have a great search at the end. So jump in with your questions, comments, well wishes, free donuts, and more. Mr. Ladyada, do you have any updates, news you want to tell people about?
Last week we moved the show to Thursday. Watch our Thursday show. That was the Ask an Engineer show. Watch it. Great show. Went over why and a bunch of other things. And also, if Ladyada can go to the computer real fast.
Of course.
So we put out a call for help. We're talking to our community that's on the ground in India, and we're going to find out if we can send PPE. We already got a hold of a few folks. Turns out they don't really need PPE, they need oxygen, and there's a couple projects that are going on. So take a look at the links that I got back from our friends that we normally just do like projects with in India and more. But there's a couple like DIY and maker-made oxygen. I guess they're called oxygen concentrators.
Yeah, they work by using zeolite to absorb nitrogen out of the air, and when you absorb the nitrogen, what you have left is the oxygen. So it's like. It's oxygen concentrating, but by removing the nitrogen part, they require a compressor and cylinders. They're very mechanical contraptions, but they can be built.
We'll see what happens. I mean, we got a chance to help folks in the U.S. when ventilators were needed, and then ultimately there was this other things like face shields, and we did those, and then electronics for you name it. We were building stuff, but we'll see what we can do with rallying the community. The thing that we can do immediately is send stuff over to India. If the hospitals need it, and we have someone looking into it now, we'll ask our carriers, our shipping partners, DHL and UPS, can we get these through imports in India for customs, because anything that's PPE gets stopped. So whatever it is, we'll keep our community updated, but just know we're on it. This is Adafruit, this is what we do. And our thoughts are with everyone over there. This is, it's every day it's been one of the highest case counts in the world, and oxygen, it might also be distribution, not necessarily the creation of oxygen.
Yeah.
It might just be the distribution of what's needed. So we're going to find out more, but we're watching this. We'll let the community know if there's things that we think that everyone can do, or even not do. You could just keep an eye on the blog post, and we'll continue to update it. Okay, with that being said, Ladyada, what is on your desk this week?
So this week we did a lot of work to add parallel capture support to CircuitPython. It's something that we actually added to Arduino. We had Arduino support for the SAMD51, but the RP2040 also has the ability to do parallel capture, and the upcoming IMX M7 chips also have a parallel capture capability, and they do like fun I/O. So basically they have a way of getting a large amounts of data through an 8-bit parallel port into the device, and these are used for camera modules, and we talked about those camera modules last week, where we showed off the header, and I showed off my design for a camera module breakout. But actually getting the support into CircuitPython, actually the Sony's presence also, by the way, they did have camera support that they added for taking snapshots, and a lot of the work with camera is actually the configuration of the camera. Like there's so many like things that you could turn on and off and move and configure and adapt. So a lot of that was not just setting up the peripheral to capture the data, but setting up the camera to send the data over to the peripheral. So the SAMD51 has a camera capture peripheral. It has the ability to like DMA, fast data into a RAM buffer. The Raspberry Pi RP2040 does it through PIOs and DMA and timers, but it can also do it. So let's take a look on the overhead at some hardware built examples, because I wanted to test out these PRs. So this here is a Grand Central with one of our TFT shields on it, and so the camera, we tried to make it as much as possible. Like we tried to line up the pins as much as possible so you could plug in the camera, but you do have to wire to the red power and black ground wires do have to be separately wired, because the Mega, which we based the circuit the Grand Central off of, has 5-volt power, and this is 3 volts. So the upshot is, and there's also SDA and SCL, whatever. The upshot is that you do have to bring the wires over. But other than that, it's very nice to plug it in. So you just cut the 2 pins off, and then plug it into the end. And then this TFT is just an SPI display. So when this boots up, you'll see it's, hold on, let me see if you can see real fast. It is, no, it goes straight. It is running CircuitPython, although you can't see it. But this is,
Is it because CircuitPython's too fast?
It's a little too fast in this case. It booted up and
it's too fast now.
It's too fast.
Oh, it's too fast now. I thought because it was a scripting language on a microcontroller, you may as well just like why aren't you cutting your teeth the right way with assembler?
Let's see if I can get it a little bit dimmer. Okay, so now you can see me. Hi, I'm in.
That looks pretty fast too.
Yeah, so this is like 8 frames per second or so, which isn't too bad. And getting the data, it's actually, I think, a combo of getting the data and then you have to convert it to 565 format and then piping it out to the display. But this just gets, it's a good way to demo. It's interesting. It has a little bit of a flicker effect. I think the camera TFT camera.
These are 3 cameras.
Is making it a little flickerier. Like you see it's a flickery effect. And you don't see that.
Everybody knows when you look at a camera on a camera. What happens.
So
but when you tilt it down, you can kind of tell something.
Yeah. So.
So here's let me just translate this for y'all keeping score at home.
Yeah.
All right. So this is what this means.
Yes. See how I can see me watching me. Yeah.
Yeah. No flicker. So this is what this means.
Yeah.
So if you're doing stuff in Python, and you want to do microcontrollers, and you know CircuitPython, or you don't even know CircuitPython, but you want to do machine learning, or if you want to make your own digital camera, or if you want the ease of use of something like CircuitPython for microcontrollers and machine learning, this is the first step. We're there. So we'll be able to do things like an animated GIF camera you can make yourself. You could do things like recognize a bird. You could do things like edge computing, just doing, is that a face or not?
Yeah.
Unconnected to the internet, not sending your stuff to all over.
On a microcontroller.
Not cloud.
In CircuitPython.
On CircuitPython.
So yeah, we've done some machine learning-y type things on microcontrollers, but we never actually got to the camera stuff. And I was like, well, if we're going to do it, I want to really get all the camera stuff working really well. So this is the first step because I think, with CircuitPython I think would be a really good match for TinyML and TensorFlow Lite because all the stuff that takes a lot of computation happens in C in the background. Anyway, the setup stuff, which is the most complicated, like loading the model into RAM, is very annoying to do in C because you have to include it as a header or as a file system.
It should show up as a drive on your computer, and you should just drag and drop the models in, like we do with our machine learning kits.
Yeah.
Yeah.
And then the computation still happens in the background, right? And something. This is the SAMD 51, so this is not even overclocked. This is just the standard 120.
You mean it could be faster?
It could be probably.
Well, you know what? Let's just not do that.
Stop! So fast. Okay, so then we also, like I said, are working on the RP2040. The RP2040 is still, it's not buggy, but there's still a little bit more we have to do. So this is the same camera.
Okay, I saw a little Blinka CircuitPython, so I know for sure this is CircuitPython. It also is very fast.
This one's I will say it's not as fast because we're still working on it.
Wow.
That said, it's a couple frames per second, and it has a little bit of a posterization effect, which you may not be able to tell, but there's something with the bit shifter.
Okay, so this is a live camera view of a live camera going into a Raspberry Pi RP2040 Pico running CircuitPython.
Right. And so this is not a SAMD. Okay. It's not nearly as fast as SAMD 51, and it doesn't have floating point support, and it doesn't have SIMD support. So this is definitely not going to be nearly as fast as the SAMD 51. On the other hand,
which is already too fast.
It has 2 cores, so it won't be fast, but maybe it'll be fast enough. So I think we could still probably do some basic vision recognition projects. Maybe tracking a red ball or something. So I have to talk to the CircuitPython team tomorrow about what we want to do with this and how we want to integrate, machine learning stuff, because OpenMV did a really good job with their MicroPython TensorFlow Lite implementation. It's not CircuitPython-y, it's MicroPython-y, which only people who've really messed with core and library and the way the API is structured, I'm okay, this is very MicroPython-y. It's very good. It works very, very well. It's also very specifically for the STM32. So
yeah, I have a repo called The Many Forks of MicroPython, and this is both the strength.
It's a great fork.
This is both the strength and one of the challenges. Everyone takes CircuitPython, they fork it, they make it their own, and then it never gets back merged into upstream.
I think it's a disparate fork. It's an excellent fork, right? OpenMV fork is awesome, and I really love the IDE. So I want to see, like, is there a way that maybe we can include it as a submodule, sort of like we did with Microlab? So I'll take a look at that. They also did some like really cool stuff. Okay, I looked at their code. I looked at the code base they have. So all the they have tons of camera drivers. All the camera drivers are in C. So they did something interesting rather than like what we did with our code. And you can even see it in our GitHub is we made the camera control libraries in pure Python and the image capture in C, obviously, because it has to be. You have to do it instantly and like DMA this full buffer of 256K. But that's it. By the way, in case you're like, hey, how these cameras are like 640 by 480. But a lot of the visual recognition stuff, by the way, doesn't need that high resolution. It runs at like 160 by 120 or even lower. I think some of the TensorFlow Lite for microcontroller projects are like 160 by 120 or 120 by 80. They're very, very small. So even this is lower resolution than what the camera can do. Like this image is not nearly as big as, some of these cameras can do like, 300 by 200, so 3,000 pixels by 2,000 pixels, bare, but still, higher resolution. I think there's something here that we can do. We can use this, and of course, you can configure the camera to send you, thumbnail images. So, okay. Pardon me. So that's this vision stuff. So this is actually pulled into Core. So if you want to try it out, the 7051 is in the latest build, which is now 7.00. We've also been doing MicroPython catch-up PRs. Scott's on a roll. I think he did 1.10 and he's doing 1.11 MicroPython. So we're going to slowly catch up. So if you've been missing the walrus operator, I think it will be merged soon. Okay, so it's camera stuff that's happening. And of course, we'll make our own breakout. And maybe we'll make a FeatherWing with camera stuff. We'll do something cool. Okay, so that's the camera stuff.
What's next?
So the next thing, also CircuitPython-y, is I saw this in the newsletter, and I thought it was cool. So let's go to the computer so I can show this off. So this is U2IF, which is an idea that I've kind of had, and I just never got to it. And I love it when people like do things that I meant to get to. Like I always hate people who are like, I had that idea first. Like I had this idea first, maybe, but I don't care because like you did it, and I don't want to do it, and like you did it for me, and this is great open source software. I love it. Like the less code I write, the happier I am. So this is a firmware for the RP2040, specifically for the Pico, where you see here the computer. This is the computer. Computer is a Python program. It has MicroPython modules, which ignore that. It's basically just the interface is MicroPython compatible. Through the U2IF interface through USB to a Pico, which then has GPIO, SPI, I2C, NeoPixel, etc. What does it sound like? It sounds like Blinka, like our Blinka support for the FT232H and MCP2221. So this is basically a firmware that turns a Pico, $4 microcontroller, into a USB to hardware interface, where then you write code on your computer with CPython. So Carter did a great job the last few days and added support for U2IF to CircuitPython library support via Blinka. So the same code that runs on a Raspberry Pi, that runs on the FT232H, that runs on the MCP221, that runs on the Pico when it's running CircuitPython, same as 7051, 7020, all these chips, same library, same code, will now run on CPython. You just load the UF2 file, right? Drag and drop the UF2 file for the firmware for U2IF, and now your Pico is like a little like a hardware dongle Swiss Army knife, which is sweet because it's so inexpensive, and it's not Fermata, and anything that's not Fermata is awesome. I've just been burned by Fermata so much. So this actually just got merged, and you can see the demo image that Carter made, which is like a breadboard with like so much stuff. So first up, he's got a button. So digital input works with pull-ups. This is a little potentiometer. Kind of barely see it. So he's testing analog inputs. He's got a BME 680, so it's an I2C sensor, LIST 331, another I2C sensor. This is a NeoPixel ring over here. A BMP 388. So you got like a lot of sensors. I think a servo going on over here. So it's PWM output. So basically, she tested everything, and it all works. He did a really good job. The only thing that it does that we didn't implement is I2S, because we're like not 100% sure how we want to expose it, because it's not normally exposed. We're not sure exactly how we want to implement that, and we don't usually provide a Blinka layer for I2S. But I2C, hardware SPI, so this TFT is a hardware SPI display, GPIO input output, PWM, and analog input. So that's cool. So added support for it, and then we went back and forth, and we did some fixes and blah, blah, blah. And basically we got it merged in like 2 hours ago. So let's go to the overhead, and I can show my little...
We're making things too easy for people to do whatever they want with their computers and their electronics.
I know. That's what we do. So here I've got... so this is a potentiometer.
I mean, like, by the way, for the longest time, all folks wanted for, like, art installations or sensors or whatever is like, look, I just want to run Python on my computer. Can I just plug electronics into it and so they can communicate back and forth?
It's just, I just want to
That's all I want.
They're like, I just want to get the sensor data into my computer.
I have a Jupyter Notebook thing. I have a spreadsheet thing.
Or they're processing.
I have all sorts of things that are already on my giant computer that could do anything. I have Python on it. I have my 15 different version of Python, just in case I have to like do different things, save them in a little pocket universe.
I actually remember like it would be like a final project at MIT, like an MIT student would have a final project of like, I want some step sensors that cause a video to play on a computer. Like that was really, really hard. Like incredibly hard. Like
here you go, kid, PhD for you.
Yeah.
And so
I mean, PhD, but it would be like a final project in an art class. Like, okay, how to make a step sensor, right? It's like two pads that you press on and it makes a contact, and then get that into a computer and have it play a video.
Yeah.
And this was like art installation.
So this is
hard. This is very easy.
This is now super duper easy. I think things with Jupyter Notebooks, people are gonna do a lot of neat stuff.
Yeah. So this is an LED. This is the PWM output, and then this is an analog input. So even though it seems like, oh, this is just the resistor for this LED, it's not. I'm actually reading the potentiometer value. Wait, hold on. Ignore this.
Botics Geek Guy says, every time I want to interface a microcontroller to Raspberry Pi regular computer, I think of Vermont and decide not to go there.
Exactly.
U2IF will change everything. Yep.
Yeah, nobody's a big fan of
does CPython run on Raspbian?
Yes. Whenever you run Python at a command line, like Linux or Mac or Windows, it's called CPython.
Yeah.
Because it's actually written in C.
Yeah.
Normally we would call it Python, but like Python is a language. CPython is the thing that when you type Python, that's the program that's running. That makes sense.
And then would you be able to like get a stemma involved in this?
Yeah, well, we had the stemma 2040 that we showed off, I think last week or the week before.
Yeah.
So one of the things I saw about this was like, ooh, I'll totally have a port for that, and that way you can just plug in your stemma boards, and that'll be a way to add any stemma stuff. Anyway, so yes, so this is an analog input, and the analog input is then converted to a PWM output. So this is actually testing two things here. And then over here, I've got, let me turn this down, this is so bright. This is a distance sensor, and then as I move my hand closer and farther away from the distance sensor, you can see I'm making the NeoPixel lights. This is my NeoPixel test. So, and very fast. And then you can see the onboard LED, that's data. So that's every time the message is passed back and forth. So this is very stable. I mean, this has actually been sitting on my desk for a few hours, and I kind of like every few minutes I sort of like noodle with it. And it's very stable. So the person who did the U2IF code did a great job. So check it out. Right. And then Blinka, we haven't done a release yet, so you'll have to wait till tomorrow when like folks wake up, and we'll do a release of Blinka, and then you'll be able to use it. And we'll also eventually have a guide. Do check out the pinout for the. You can't just use any pin for anything. The I2C pins are kind of like fixed. There's only a couple. You know what I mean? Like they don't. It's not as flexible as CircuitPython, where it's like use any pin for like anything you want. You have to. There's some pins for some things. It also does a UART mode. Also, we have to add UART modes.
You got anything else, or you want to do some searching?
Okay, so that's my desk, and so let's head into the great search because I just shut off all my hardware.
Where in the world is that part I need? The great search with DigiKey.
Great Search is brought to you by DigiKey. Thank you, DigiKey, for helping make the Great Search happen every single week. Ladyada uses their powers of engineering and more to navigate the DigiKey site to search for all the parts and components, and we take requests. And speaking of,
we did
what's
have
this
a
week's?
request. Well, we have 2 requests, so we're going to do with one this week and one next week. So somebody posted on the forums, and they asked. Let's go to the computer.
Boop.
Okay, they want a latching power relay like the Omron G6C. So basically, they said, look, they want a power latching relay FeatherWing. This is what we've got now. This is the power relay FeatherWing. And the power relay FeatherWing has a big sugar cube Omron relay. And, you turn the relay on and it moves the the throw over to the other pole. And so the middle pad of this terminal block connects to the one or the other, from the sides, either the left side or the right side. This is a really nice, high voltage friendly, and we have a cutout, and it can handle pretty high voltages and high current. So this is 1200 watts. So it can do 5-10 amps of current for like a small appliance. Like it can definitely handle a small toaster oven or lamps, fans, trying to think like small heaters. Televisions, etc. Appliances, things around your house that use wall power, motors, etc. So this FeatherWing, though, the relay that it uses is a power relay, but you have to hold the pin high to keep it connected. So basically, like if you want it to only turn on when you turn the relay on, right? You want the contacts to close to create the circuit when the relay's on, you have to hold that pin high, which does use a lot of current. And the alternative to a normal relay is a latching relay. And a latching relay, you don't have to hold the pin high or energize the relay. You just toggle it, and it sort of like clicks and latches the relay into one position, and you move another pin, and it latches the relay the other direction. And we do have a latching relay FeatherWing, but it's only this mini style. So you see there's a latching and non-latching. So this one is latching, and it takes 2 pins, a set and unset pin. But this relay is much smaller. This is a telecom relay, so it's only like maybe a half an amp. Not very high power. It takes 70 watts or so, compared to the other one, which is over 1200 watts. So this person had a good point, though. I was like, oh yeah, I never made a latching power FeatherWing. I should do that. I should go DigiKey and search for that, because finding a latching finding a latching relay that'll fit on a feather is not necessarily easy. A lot of relays are really big. We want something that's really slim. So let's go to the overhead real fast, and I'll show that. So this is, I happen to have at home a relay FeatherWing. So you can see it's it's kind of chunky, and this is about 15.5 millimeters by 21.5 millimeters by about 18 millimeters, and it's soldered onto this FeatherWing. There's it's not taking up all the space. I do have a little bit of room over here, so it can be a little longer, but I really don't want it any wider, because you see it's kind of getting near the edges of the FeatherWing. I want it to be narrow. So let's make sure that we get one that's narrow enough that it fits onto the feather. It can be a little tall. I mean, it's a sugar cube. It's chunky, but I don't want it to be longer than the feather, wider than the FeatherWing. All right, so let's go to DigiKey. So let's go to the computer, and I'll do the searching. Okay, so let's search for relay to start. And you're like, why don't you search for latching? Because if it's latching and non-latching, I'd rather just go to the relay section and then search. So, okay, so there's power relays and signal relays. So signal relays, again, like telecom relays, they're less expensive, they're smaller, they're often surface mount, but they don't do high power. They do less than 2 amps. Now, granted that 2 amps is, is it at low voltage or high voltage? Either way, I definitely want it to be 5 to 10 amps of current at 240 volt AC. So I definitely don't want the signal. I want the power relay. There's also solid state relays, which are going to be They're different. I think, they're not going to be latching. They work in a different way, and they don't work for DC voltage. So I want to make sure that this works for AC or DC. I want the mechanical relay, so let's go to the power relay section. So I have 22,000 relays. So let's go with active, because I want only ones that are I'm going to make a product out of this. Now, normally I would only click in stock, but because there's been so many shortages of components, I'm going to click normally stocking instead, because I want to make sure there could be good ones that are just not in stock right now, but they will be in a couple weeks or maybe a month or two. I want to find what's the best possible thing, because relays are very specific. They're not like some components where it's like some silicon components where it's like, well, the op amp or the transistor, I'll just find whatever it is that's good enough. I really, when I pick the one I pick, the mechanical shape is going to be very specific, and it's not going to be easy to go to a different one. So I really kind of got to pick one and be done with it. Okay, so next up, the next thing that's really important is the coil voltage. So because it's going to be on a FeatherWing, it has to be powerable from feathers, and feathers are 3-volt logic. They get 5-volt power from a USB, but they can also run off of a battery. And in fact, this person who posted said they wanted to run off a battery, which is why they wanted to be latching. And the batteries, they're 4 volts or so, but really, they can start dipping down to 3.5. So I don't want to require a 5-volt relay. I want it to be less than that. I think 3 volts or less. To even 4.5 volts is a bit high, because remember, LiPo batteries, 4.2 volts is about as high as they get, and I don't want to risk it. You know what I mean? I want to make sure that if they want the relay to activate or deactivate, that they can do so. So the coil voltage, I'm going to select 2.2 to 3 volts. And you'll see this really reduces the number. Right now I think I have like 6, we went from 20,000 to 6,000, to now it's only going to be 89 options. Okay, so next up, there's a couple things like coil insulation or must operate voltage, but none of these are important. So there's now 2 kind of coil types, right? Because this is why are we here? We're here for the latching. So the next question is, do you want single coil or double coil? And I actually didn't know the difference between double coil and single coil until I had to go look for this, because it usually didn't matter. But when I picked, double coil is a little simpler to use. Double coil is you have 2 pins, and when one goes high, the relay latches one way, and the other pin goes high, it latches the other way. Right? So each pin, when you toggle it high. However, what I noticed is that I had a lot fewer options with double coil than single coil. There's more single coil options because I think the mechanical construction is a little simpler. So I will select both, but I will note that single coil is a little easier, and I'll show you how we're actually going to use it when we get to use it. Okay, so the next step is, do we want single pull, single throw? Not really. Single pull, single throw means it really is either connected or not connected. I like to have it be normally open, normally closed if you have 2 options. So I'm going to pick the SPDTs and the DPDTs. So you can have something open or close, and they pick which way they want it. Surface mount or through hole. I don't think I'm going to find a surface mount one, but I'll leave it all selected. Okay, so going down here, I'm going to view the prices at 500 pieces, just because relays, like one relay is usually like $10, and they quickly go down in price, so I want to compare them at a reasonable price. So yeah, there's a couple of good options. So this one is sneaky. So there's this telecom relay, and you're like, wow, this is surface mount. It looks pretty small, and there's 10,000 in stock. This looks great. The problem is that I actually went and looked at the data sheet. Hold on. Which hopefully will load. Uh-oh. Oh no, data sheet. You can do it. Okay. So when you look at the data sheet, even though it's in the power relay section, if you look at the load, the current is 5 volts, 5 amps max, but only at low DC voltages. And as you get higher, it definitely goes down. And so I think it doesn't seem to. It said it was okay for AC, which is probably going to be the same as DC. But basically, it's a signal relay. It's not a power relay. So even though it's in this category, and it was like very attractive looking. So the next one I looked at was the Omron one, and the reason is it's like, well, I know Omron ones and they look pretty good. It's inexpensive. It's not in stock right now, but I know that they're normally in stock. I also looked at this TE one, although the pricing is significant. Like this one's $250, and then they get to $4 quite quickly. And I do have to keep it price sensitive. So let's look at this relay. So this is a high switching current general purpose latching relay. That's kind of what I want. So this one, this is a confusing data sheet. Okay. So for this one, the thing I noticed was for the single winding latching type, you'll see it goes down to 3 volts rated, 200 milliamps. But if you are 5 volts, hold on, this is like the trickiest data sheet. Hold on. Sorry, this data sheet, it has like this weird page that kind of flips it. Okay, let me move this over. Okay, you see it. Great. So for the double latching type over here, you'll notice that it doesn't have a rating voltage lower than 5 volts. And that's why, I was having this issue where I was like, oh, I want the double coil because it's easier to deal with. However, when I did double coil, I didn't get to find this particular relay because only the single coil version has 3 volt activation. So the difference in how you use it, and let's again hold on, go to see this data sheet. It's like wide. It's kind of an interesting data sheet. So this is a single coil relay. This is what it looks like. So you see there's one coil and there's one pin, and then when one pin is high and one is low, it pulls the armature one way, and then when you invert it, so the other pin is high and one pin is high and the other is low, the armature moves the other way. Why does this matter? So normally, if you have a double coil latching relay, of course you have to put a lot of current through the coil. So you're going to have 2 transistors, one for each coil, to help you drive that current through the coil, right? So it's basically like a solenoid. You have 2 power transistors of some sort, enough that can pass 200 or 300 milliamps. And then you can turn each one, high or low, using that power transistor. With a single coil relay, you have to treat this like a motor. It's kind of like a bidirectional motor. So you actually need an H-bridge for this because you need to pull a lot of current through one way and then pull a lot of current the other way. It's basically an H-bridge. A little more annoying because now you need 4 transistors instead of 2. However, it's $1.50 less in price and there's more options available. So, I'm probably going to do that. It's not a big deal. You can make an H-bridge out of 4 transistors. It doesn't have to be a great H-bridge because it doesn't have to stay on for a very long time. It just has to be on long enough to latch the relay one way or the other. So it can be like a kind of like, you don't have to use the best transistors in the world. That should be good enough. And then you just have to have 4 diodes as well as flyback diodes for this. But basically you have to treat it like a motor. This is the single pulse, single throw version. And, oh man, this data sheet, man, it's kind of weird. And this is the double pull, double throw. So this is the one I'm actually going to get. And I'm just going to double up. It has, multiple pins for some reason. I don't know why. They're actually inside. It's only one relay, so I don't know, twice as much current goes through. Maybe, I don't know. And then, again, this sneaky. I do not like this data sheet. Okay. And then over here, you can see if it's a single double coil, you see how it works inside. It is one coil, but it's doubled up, and then you have to kind of like pull it from the middle And that's why I guess you can't use it with 3 volts. This is 5 volt only. But I need 3 volts. So, my decision's kind of been made for me. That's okay. It's a pretty good relay. So let's, next up, now that we've decided, okay, we're going to do the H bridge, we're going to do the single coil. Let's look at the mechanics. Oh my God, this data sheet. Okay, well, these are all mechanically the same size. So this is 29 by 12.7 by 15.5. So let's go to the overhead again real fast and we'll see how this compares. So lengthwise, this one is 22 or so, and the one we're picking is about 29. So I like to sort of measure it. So it's going to be a little bit longer, but not, it's not longer than the feather, so that's fine. And then for width, it's going to be 12.7, and this is 15.5. So it's going to be thinner. It's going to be kind of significantly thinner. It's going to be a little thinner. It's going to be skinny like that. And then for height, it's 15.5 millimeters, which is, I'll just do it here, and you'll just have to trust me. So that's about 15.5. So it's actually a little bit shorter as well. So it's basically going to be a longer, thinner, shorter version of this relay, but it'll definitely fit on the FeatherWing. So I'm going to order some of these samples. Since the 3 volt one isn't in stock, I'm probably going to pick up like the 6 volt one, and then I'll just like jury rig it to get it tested and trying it out. I'll feed it 6 volts, and then get the mechanics set up, and then I'll be able to convert it to the 3 volt version when I finish, and then do the testing before I release the product. So the winner of this week's The Great Search is this Omron G5R LU1E DC3. You are the winner of this week's Great Search. Thank you.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, so here's some questions that came
Great.
in, and someone's typing one up.
Okay.
So we'll get to a few of them. Someone said I could see using SBC, using the U2IF to talk to one or more microcontrollers or small cameras. Mind blown. Yep. So does that relay need an H bridge?
It does need an H bridge,
Okay.
so I'm gonna have to craft one up. But I'm just gonna use some, FET transistors, whatever I've got, and I'll just lay them out.
All right.
I'm not gonna use like a motor driver. I don't need something that good because again, it only needs to pulse on. I don't have to
Alright.
worry about low resistance in the transistors because they're only pulsed. They're not going to be on for a long time.
And then one of our friends from Show and Tell who had their open source power chair, they're starting with a retro kit to get old power chairs functioning again. Basically, strip the chair down to the frame, seat, and motors, putting it the kit, and the kit will be completely open source. So there's a couple of biz questions, and I'm going to always say we can't give legal advice, but we'll give you advice.
That's
and
right.
we'll share our stories.
I can give some engineering
Yeah.
advice, but I can't give
So
legal advice.
here it is. I was talking with a lawyer that volunteers with SCORE, and he kept talking about a lot of pressing to get my thing patent, and what I'm doing is intentionally easily duplicatable. So to me, what's the point of patenting? Then I wonder if he's just really just practiced what true open source is in product production. So here's what I will tell you. At this stage, and based on the project you're doing, it doesn't make sense to do a patent at all, because you should start to get it out there. You should publish. You should put it up online. And I know, a lawyer will say things like, "Well, once it's out, someone can be first to file." It's much better to get it out than to worry about this. It's kind of like spending forever thinking of a company name or a logo. Get that idea out of your head.
And you have a year to file.
Well, even if you didn't, it's okay.
Yeah.
And the things that are worth protecting are not things like modifying a power chair and making it open source and reusing it. That's not something that's like, oh my gosh, I need to protect this because this is such a big idea that we've invested millions in.
Mm.
Get it out there and do the best you can and publish it, and use that to move on to your next big idea, your next big project. At some point, if you get enough things going and you have an electronics company or if you have an invention company, then try your hand at patents. We are not a hypocrite. We decided to try to get one patent just so we could give it away And the process was so long, by the time it was finished, we already released like 1,500 new products. So if we only sat around and waited for a patent to get approved, we would just be 1,500 products short.
Yeah, lawyers will always tell you to patent stuff because they make money when you patent stuff.
Yeah, and it for patents is great for some people, but for what you're doing and you want to be in the open source community and you want to do all this stuff, do this, and you can always think about it later. But trust me, this isn't the thing to spend that time and that money on. It's
Yeah,
not.
it is a lot of
You're
time.
basically repairing.
I haven't seen any
power
company. I haven't seen any company succeed or fail because of a patent thing.
And at the higher level, they just use these nuclear arms.
Yeah.
It's like, well,
It is.
we're going to nuke you with our patents, and if you nuke us with your patents.
Yeah, it's Cold War patent diplomacy.
So.
All right, any other
Yeah.
other
Let me see.
questions?
No, this is what we're here for, to
Yeah.
give this type of advice. Let's see. This is the first stream of y'all's I properly caught. Just received my DigiKey orders that I made thanks to the power of Ladyada and the Great Search. Yeah. This works.
Great power.
You watch the Great Search.
From great power comes great searching.
You save a lot of time, and then you place orders. Okay. I assume resetting the latch is why you need an H-bridge, so could you use a non-latching and avoid the H-bridge, or do you need latching for some reason?
If you check out the post, the person really wanted a latching relay. So that was not debatable.
Okay. All right. I'll see if this other question comes in, and then. Are the T-shirts like Ladyada is wearing available now?
No, and Pedro made this for me. You can check. They have video streams where they show how to make your own T-shirts by ironing. They do iron on.
So we have this thing where we just don't put the Adafruit logo on stuff besides our circuit boards.
Yeah, we don't do that.
I've seen a lot of like tech companies put like their logo on shot glasses and like all sorts of stuff. This is not our vibe. Like we're just like, well, let's keep the logo special. So when you see it on something like a circuit board, you're like, oh, this is.
Yes, you can buy circuit. You can buy.
But
our
we do
logo
appreciate it. I want to do something.
You can make a T-shirt out of circuit boards.
Yeah, I want to do something in the lines of clothing and apparel, but
Yeah.
All right, so I think that's it.
All right, thanks everybody.
We'll continue to answer biz questions each chat, so just save them up for you, and that's it.
All right, thanks everybody.
All right, see you during the week, and once again, please continue to check our site. We're going to try to check in with our friends, family, community in India and see what we can do. Oh, let me just make sure this one just came in. The whole idea is making this to get people mobile. To me, it's the idea of helping people who want to produce consumer. Yeah. Okay, great. So, lawyers will tell you. Here's my in closing. You won't get a direct answer out of a lawyer either. If you say, "Should I patent this?" They'll say, "Well, if you don't patent it, then you can't patent it." Like they won't tell you. They won't look at your idea and say, "Hey, this doesn't make sense for this." Lots of other things totally make sense for patents. Even as flawed as a patent system is, there are reasons for certain things. And I would always say like, oh yeah, like you just invested like $45 million in this thing that, helps discover the X and the Y and the Z, and it's a process and you want to recoup your money over the course of a few years. Sure, patent is kind of like a thing. But there's other things too. There's copyright and trademarks. Even when you do open source, people have to abide by the license because it's copyright. And for trademarks, you can trademark the name of your invention. You can just say, hey, copy it all you want, just don't call it that. So you have lots of things. And then someone's going to ask, can I put the logo, the show and tell on shirts? Yeah, sure, you can do that. Just do it for you. Don't sell them because that'd be weird. Just do it for yourself. Okay.
All right, thanks
With that,
everybody.
all right, bye everybody.
Bye.